Hello, I'm Andrew Thomas, and this is my short explanation on how varying launch speed, elevator deflection and centre of gravity location can affect the flight dynamics of a paper aeroplane. This is the paper aeroplane I chose to work with. I chose it because it's easy to make and had pretty consistent levels of trim flight. During all the flight trials, I will be attempting to throw the plane from the same height and at the same angle of attack. This being the angle between the airflow and the angle of the aerofoil, as opposed to pitch, which is the angle between the aerofoil and the horizontal determined by gravity. It's quite obvious that with an increase in launch speed, there's an increase in distance travelled by the paper aeroplane, with each flight finishing with quite a clear nosedive. Lift is calculated by this equation here, which has a velocity squared component, which means with a higher launch speed, more lift is created. As the flight continues, work is done against forces like drag, which means kinetic energy is lost. With a decrease in velocity, there's a decrease in the amount of lift, which means weight becomes the dominant force. With the centre of gravity located towards the front of the plane nosedives. Elevator deflection affects the angle of attack of trim flight. In this case, there are small folds at the rear of the paper aeroplane, which when untouched, the plane's flight is determined mainly by the way it is launched. When the elevators are bent upwards, it is known as positive deflection. When they are bent downwards, it is known as negative deflection. For this plane, with any negative deflection, it causes the plane to nosedive dramatically. When the elevator is deflected positively, more downforce is created at the back of the plane, causing the angle of attack to increase. This creates more lift. When there is too much positive deflection, the angle of attack increases to the point where the plane stalls. A stall happens when the airflow detaches itself from an airfoil. When it is attached, a Newton's third law pair generates lift by the force of the air being deflected downwards and the reaction force going upwards. This pair does not exist when the air becomes turbulent underneath the wing. The centre of gravity greatly affects the trim flight of an aircraft. I altered the position of the centre of gravity by sellotaping a 5p coin to various places inside the centre fold of my paper aeroplane. Placing the coin at the back of the aircraft had a very similar effect to negative elevator deflection, causing the plane to pitch upwards and stall. When I placed the coin at the front of the aircraft, its gliding improved. This is due to a slight acceleration downwards, increasing velocity but also increasing lift. All three components, elevator deflection, centre of gravity location and launch speed, can be altered to make trim flight as efficient as possible. I found moving the centre of gravity to the front of the plane with a slight positive elevator deflection caused for a very smooth glide.